Welcome back. In the last video, we checked out a few different options for getting a GPU and then getting PyTorch to run on the GPU. And for now, we're using Google Colab, which is the easiest way to get set up because it gives us free access to a GPU, faster ones if you set up with Colab Pro, and it comes with PyTorch automatically set up to use the GPU if it's available. So now, let's see how we can actually use the GPU. So to do so, we'll look at putting tensors and models on the GPU. So the reason we want our tensors/models on the GPU is because using a GPU results in faster computations. And if we're getting our machine learning models to find patterns in numbers, GPUs are great at doing numerical calculations. And the numerical calculations we're going to be doing are tensor operations like we saw above. So the tensor operations, well, we've covered a lot. Somewhere here, tensor operations, there we go. Manipulating tensors, tensor operations. So if we can run these computations faster, we can discover patterns in our data faster, we can do more experiments, and we can work towards finding the best possible model for whatever problem that we're working on. So let's see. We'll create a tensor, as usual. Create a tensor. Now the default is on the CPU. So tensor equals torch.tensor, and we'll just make it a nice simple one. 1, 2, 3. And let's write here, tensor not on GPU. We'll print out tensor, and this is where we can use, we saw this parameter before, device. Can we pass it in here? Device equals CPU. Let's see what this comes out with. There we go. So if we print it out, tensor 1, 2, 3 is on the CPU. But even if we got rid of that device parameter, by default, it's going to be on the CPU. Wonderful. So now, PyTorch makes it quite easy to move things to, and I'm saying to for a reason, to the GPU, or to, even better, the target device. So if the GPU is available, we use CUDA. If it's not, it uses CPU. This is why we set up the device variable. So let's see. Move tensor to GPU. If available, tensor on GPU equals tensor.toDevice. Now let's have a look at this. Tensor on GPU. So this is going to shift the tensor that we created up here to the target device. Wonderful, look at that. So now our tensor 1, 2, 3 is on device CUDA 0. Now this is the index of the GPU that we're using. Because we only have one, it's going to be at index 0. So later on, when you start to do bigger experiments and work with multiple GPUs, you might have different tensors that are stored on different GPUs. But for now, we're just sticking with one GPU, keeping it nice and simple. And so you might have a case where you want to move, actually, the reason why we set up device agnostic code is, again, this code would work if we run this, regardless if we had, so it won't error out, but regardless if we had a GPU or not, this code will work. So whatever device we have access to, whether it's only a CPU or whether it's a GPU, this tensor will move to whatever target device. But since we have a GPU available, it goes there. You'll see this a lot. This to method moves tensors, and it can be also used for models. We're going to see that later on. So just keep to device in mind. And then you might want to, for some computations, such as using NumPy, NumPy only works with the CPU. So you might want to move tensors back to the CPU. Moving tensors back to the CPU. So can you guess how we might do that? It's okay if you don't know. We haven't covered a lot of things, but I'm going to challenge you anyway, because that's the fun part of thinking about something. So let's see how we can do it. Let's write down, if tensor is on GPU, can't transform it to NumPy. So let's see what happens if we take our tensor on the GPU and try to go NumPy. What happens? Well, we get an error. So this is another huge error. Remember the top 3 errors in deep learning or PyTorch? There's lots of them, but number 1, shape errors. Number 2, data type issues. And with PyTorch, number 3 is device issues. So can't convert CUDA 0 device type tensor to NumPy. So NumPy doesn't work with the GPU. Use tensor.cpu to copy the tensor to host memory first. So if we call tensor.cpu, it's going to bring our target tensor back to the CPU, and then we should be able to use it with NumPy. So to fix the GPU tensor with NumPy issue, we can first set it to the CPU. So tensor back on CPU equals tensor on GPU dot CPU. We're just taking what this said here. That's the beautiful thing about PyTorch, is very helpful error messages. And then we're going to go NumPy. And then if we go tensor back on CPU, is this going to work? Let's have a look. Oh, of course it's not, because I typed it wrong. And I've typed it again, twice. Third time's a charm. There we go. Okay, so that works because we've put it back to the CPU first before calling NumPy. And then if we refer back to our tensor on the GPU, because we've reassociated this, again, we got typos galore, classic. Because we've reassigned tensor back on CPU, our tensor on GPU remains unchanged. So that's the 4 main things about working with PyTorch on the GPU. There are a few more tidbits, such as multiple GPUs, but now you've got the fundamentals. We're going to stick with using one GPU, and if you'd like to later on, once you've learned a bit more, research into multiple GPUs, well, as you might have guessed, PyTorch has functionality for that too. So have a go at getting access to a GPU using Colab, check to see if it's available, set up device agnostic code, create a few dummy tensors and just set them to different devices, see what happens if you change the device parameter, run a few errors by trying to do some NumPy calculations with tensors on the GPU, and then bring those tensors on the GPU back to NumPy and see what happens there. So I think we've reached the end of the fundamentals. We've covered a fair bit. Introduction to tensors, the min, max, a whole bunch of stuff inside the introduction to tensors, finding the positional min-max, reshaping, indexing, working with tensors and NumPy, reproducibility, using a GPU, and moving stuff back to the GPU. Far out. Now, you're probably wondering, Daniel, we've covered a whole bunch. What should I do to practice all this? Well, I'm glad you asked. Let's cover that in the next video.